Right, so moving on to example number 3 here. So we're going to be talking about revenue and costs in this one. So Reach for the Top is an academic challenge program offered to students across Canada. Suppose the cost of t-shirts for the program includes $125 in fixed costs and $7.50 per t-shirt. The shirts are sold for $12 each. So for part A here, we need to write an equation to represent. So our first one there is the total cost, C, as a function of the number N of t-shirts produced. And our second one that we need to create there is the revenue R as a function of the number N of t-shirts sold. So our first one there is our total cost, so that'd be C. We're going to be dealing with, normally we represent this using C of N. We're dealing with our little X coordinate there will be N instead. So here we know, what do we know about the cost? So suppose the cost includes $125 in fixed fees. So that means even if we don't sell any t-shirts, we're going to have a $125 fee. And then it's going to also be an additional cost for $7.50 per t-shirt. It's be 7.5 per t-shirt. So be if we had N number of t-shirts, it'd be 750 N. And then our revenue there. And we're dealing with our variable of N there again. So your revenue is equal to the number of t-shirts sold, and what we know is that they're sold for $12 each, so it'd be 12N. And if we can, maybe let's talk about some restrictions here. We can't have a negative number of t-shirts produced, so we need to have that restriction that N must be greater than or equal to 0. We can sell 0, but we just can't sell a negative number. Alright? And same here, so we shouldn't have a negative number of t-shirts sold, so N must be greater than or equal to 0. Okay? So that's it, that's all for part A. So now let's move on to part B there. So part B talks about profit. So profit is the difference between revenue and cost, and now we need to write a function representing P in terms of N. So here, basically what this first sentence here says that we have profit, so we'll label that P of N is equal to the difference between revenue and cost. So you take your revenue, subtract your cost, and then we just plug those functions in. So we have P of N is equal to, and if you guys remember, your R of N was equal to 12N. And your cost was equal to negative, so that'd be your cost, which was 125 plus 7.5 N. Alright, so then from there let's just simplify. We'll distribute this negative to both of those terms. So we have P at N is equal to 12N minus 125, subtract 7.5 N. Then you can combine like terms, and here we have that P of N is equal to 12 minus 7.5, so that'd be 4.5 N, subtract 125. Alright, and instead of talking about the domain here, we'll talk about it in part C here. And if you guys can probably think about this already. You know, you can't have a negative number of t-shirts, so you guys might be able to think about what your domain will be. But if anything, let's use what we learned earlier about what we know about our revenue and cost domain. What happens if we know those two? What does that mean for P of N? So our domain was C of N. So to write the domain, we have D colon fancy bracket N such that N. And there we had that restriction that we can't have a negative number, so it must be greater than or equal to 0, or N. And we can say that N is an element of all real numbers, or you also could say that it must be, say, whole numbers. If you were to graph this and say you use really big numbers, you could, in theory, label this as X is an element of all real numbers, but you also can't have a half of a shirt sold. So if you want to, we can label this as N is an element of whole numbers. So that'll represent from 0 to 1, 2, 3, 4, 5, and so on. So it's greater than 0, and it's whole numbers there, okay? And so for R of N, it's going to follow along those same lines. So we have D dot dot fancy bracket n such that n, and once again we have the same domain here, so n must be greater than or equal to 0, where we can also say that the number of t-shirts sold must be whole numbers. We can't have half of a t-shirt sold, or a quarter of a t-shirt sold, or a third of a t-shirt sold. So I want to make sure that those are in some appropriate values. So just remember, if you were dealing with a big graph with really big values like 100, then you could go with x as an element of all real numbers. But because we used, or we didn't even create a graph, we will just say that it should be whole numbers that are greater than or equal to 0. Okay? And then so to find your domain for your P of n, this one, if you guys remember, this is your overlap between the two functions. And if you notice, they are the exact same domain, so that means that P of n will have that exact same domain as well. So we have n such that n must be greater than or equal to 0, where n must be an element of whole numbers. And close it off with a nice fancy bracket there. Alright, so just make sure that is the overlap. If you didn't graph it, you can tell it from, or tell it apart just by looking at the two domains and seeing where that overlap there is. Okay? So from now here on out, we're all done our examples, so you guys can get a start on your homework, and let me know if you guys have any questions.